Okay, assalamu alaikum guys. We solve this in class. So this, I will not have time to solve it tomorrow, inshallah. So I would like to solve it. I would like you to solve it. And here are my comments. I'm commenting this, okay? So let's look at this problem, example number 7. So what is given here is this airplane flies horizontally and at constant speed and at constant elevation, mean horizontally. So the elevation is 400 meters above the ground. The plane now released an object. So this object here will have the same speed as the speed of the plane. Will have the same velocity as the velocity of the plane. So to hit the target, to hit a target on the ground, let's say the target is here in blue, what should be the angle phi of the pilot's line of sight to the target when the release is made? So the pilot is here. He look at the target. Now the question is, what should be the angle between this blue line connecting the pilot with the object to the target and this? Okay. Let me call it phi. Okay. Okay. As the students, they will take this one angle here, but you know that this angle is just 90 minus phi. So if I know phi, I can know 90 minus phi. But here what I want is phi. Now what did I give you here? I give you the initial velocity of the object. Okay. And it's purely along x. And I give you the initial, basically height, okay? The elevation. Now, I will choose my origin at the release point. So at the release point, I will take it as my origin, of course. So x0 and y0 is equal to 0, as usual. At t equals 0, I put my position at the origin. Now, of course, this is what I said earlier. Since the object is released, not thrown or not ejected, the initial velocity of the object is the airplane velocity. And by the way, the airplane velocity is 80 along x and 0 along y. It's a purely directed along x. Okay. So v naught x is v naught is equal to plus 80 meters per second. V naught y is equal to 0, as I wrote here. Okay. Now, what is the distance, the horizontal distance between this point and this point? This is, I call it r. By the way, this r is not range. Okay, so don't use the formula of the range, because I told you for range you have to start at the same height and end at the same height. So this angle phi here that I want will be tangent of range divided by h. Tan inverse, sorry, of r divided by h. So in other words, I'm just asking you, what is this r here? I know h already. H is equal to 400 meters. Once I get r, the initial, let's say, horizontal distance between the plane and the target, basically this r, if I know it, I know my angle phi. Okay. Now let's get r. How will I do? I will use the projectile equations. Okay. This is the first equation that you know. X minus x naught for a projectile is v naught x t. And y minus y naught is equal to v naught y t minus half gt square. Of course, v naught y is 0. So I just have y minus y naught. Basically, it will be equal to what? Minus 400 plus h. The displacement is negative, is equal to minus half gt square. Okay. So here I can get the time. Once I get the time from this y, from this equation, I plug it here and I get my small r. So the time is square root of 2h divided by g. Now let me plug it in the range now. Not the range, it's not a range. I just call it r, but it's not a range. I plug it here and I get my r, which is equal to this. So now I know my r, I know my h. I just use the tan inverse of r divided by h, and you will get an angle of 61 degrees. Okay. Clear? Now let me go to the next one. Now, as the object reached the target, what is the velocity in unit vector notation and in magnitude angle notation? So now my velocity, when it reached here, as I told you, the velocity will be tangent to what? To the path, to the trajectory. Now the question is, what is Vx and what is Vy? Even without calculating, I know that Vx will be positive and Vy will be negative. All right? Now let's calculate it. How we will do, we already know that the time I reach the target is this, square root of 2h divided by g. I know also my v naught x, and I also know my v naught y. I also know my ax, which is 0, and I know my ay, which is minus g. So let me use my formulas. Of course, I know that vx is constant, is v naught x, because ax is 0. So vx is equal to plus 80 meters per second. So this vx here is equal to v naught x is equal to plus 80 meters per second. And v naught y, I know vy is v naught y minus gt. I know v naught y, which is 0. I know g, 9.8. I know t, which is here. I will just plug in minus gt, and I use my calculator, and I get minus 89 meters per second. This is the velocity in unit vector notation. V, when I hit the target here, has the same constant value along x, which is v naught x, which is 80, which is the velocity of the plane, meters per second along I hat, minus 89 j hat. 89 because it's going downward, minus, going downward. Now, once I get it in unit vector notation, I can get it in magnitude angle notation or magnitude direction notation. Of course, magnitude of v will be vx squared plus vy squared. So magnitude of v is square root of 80 squared plus 89 squared. And this will give me 120 meters per second. And what is the angle? Tan inverse of the y component minus 89 divided by the x component, which is plus 80. You look at it, and this will give you minus 48 degree. Minus 48 degree is in the fourth quadrant. And you look carefully here, of course, your vector is in the fourth quadrant. So this is equal to minus 48 degree. So what the calculator gave me is a correct answer. Okay. If, what? That's another story. Now let's look at this example here, example 9. Now here I give you the range. I give you the initial speed of my projectile. Now that I'm asking you about the angle. At what angle from the horizontal, I'm asking you about the launch angle, theta naught, must a ball be launched to hit this target, which is at this range, 50 range, because you see, delta y is 0. Y of the initial position is equal to the y of the final position. Well, you know the formula for range. Now you can go directly for the formula. If you don't remember the formula, or you don't have your formula sheet, you can get it. But you know that here, final height is the same as initial height of the projectile. You use the range formula. Range capital R is V naught squared divided by G sine 2 theta. So here, what do I know? I know R, 500. I know V naught, 80 meters per second. The only unknown is theta. So I just take the sine, arc sine or sine inverse of this number, then I will get my theta. Using my calculator, it will give me 50 degrees. But you know that sine theta is equal to sine 180 minus theta. Okay. So let me just show you that. If I am in the trigonometric circle, sine of this angle here, by the way, sine is a y component, because this is the opposite, is equal to the sine of this big angle. And by the way, this big angle is 180 minus theta. So if theta is 50 here, this big angle is 180 minus theta. Okay. So basically the calculator will give me 50, but I know also that 180 minus 50 will give me a correct solution. And this is due to the sine, y basically, the property of sine, okay? Again, in a trigonometric function, in a trigonometric circle, the y coordinate will give me what? The sine, and the x coordinate will give me the cosine. You see that the cosine are opposite to each other. So you know that sine theta is sine 180 minus theta, but cosine theta is minus cosine 180 minus theta, because you see it. This is cosine theta, and this is cosine 180 minus theta. So I have two angles that will give me the same range. So these two angles are just half of 50 and half of 130, and it just will give you 25 degree and 65 degree. And you see, when I add them, they give me 90 degree, okay? They are complement, okay? Complementary angles. The sum of these two angles will give you 90 degree. So for each range, you will have two angle, angle larger than 25 degree, an angle larger than 45 degree, and an angle smaller than 45 degree that will give you the same range. So when I fix R, I have two angle, launch angle theta, which is larger than 45 degree, and another theta naught, which is smaller than 45 degree. But when I add these two angles, they are complements. Basically, their sum will give you 90 degree. Now, yes, this is the small angle, okay? And this is 25 degree, and this is a large angle, theta naught, and this is equal to what? 65 degree, but the range is the same. Now, this question is straightforward. What is the maximum range? I give you V naught, okay? Now, well, I have maximum range. It corresponds to 45 degree. Theta is equal to 45 degree. So maximum range is just equal to V naught squared divided by G, because this is equal to 1. Okay, and I just plug my numbers and I get 653 meters. Now let's solve this example. Okay, let's say this is a gentleman who is at Venice Beach, motorbiker, let's say, and let's consider him as a projectile. There is no wind on Venice Beach. There is no wind in Corniche in Jeddah, and you have these ramps. So the motorbiker went from this launching ramp and then landed on this one, landing ramp. There is no wind, so projectile motion, let's say. So the launching ramp is identical to the landing ramp, okay? This angle here is theta. And theta, I give it to you. Theta is equal to 20 degree here in this problem. It was designed this way. The distance between here and here is 50 degree. Okay, this distance, no, sorry. This distance is 50 meters. The height, this height here, h, is equal to 4 meters. So the question is, if the gentleman is landing right here, and by the way, right here is halfway down the ramp, meaning halfway down this hypotenusis, but also halfway along this height here. So the gentleman is landing halfway down the landing ramp. So basically halfway here, this and this are equal in distance, so halfway. But also this is h over 2 and this is h over 2. So if the gentleman wants to land here, what should be his launch speed when he left this? Okay, what should be his speed? Because I already gave you the launch angle. The launch angle is 20 actually, because he is following this launch speed, this launch ramp. So here's the question that I want is, what is the launch speed? What is V naught? Now let's exploit the data of the problem. So when he arrives here, he has an initial velocity. I know the direction, 20 degrees, but I don't know the magnitude. And this is a question, magnitude of the velocity. Now, I will choose always the origin of time to be the launch point here. The origin of position, sorry. So this, my origin will be here. I will take it as x 0 and y 0. It will be equal to 0. I will plot my xy axis. You see, my x-axis is here and my y-axis is going upward. Y, and this is x. Now at t equals 0, I am at position 0, 0. Now, at t equal final, t final, I landed here. Now at t final, you have to know what is a vertical displacement. Since I landed halfway down the ramp, that means with respect to here, I landed halfway h below this 0, actually. Okay? This is a 0. So I landed minus h divided by 2. So if I know h, which is equal to what? 4 meters. So my final y is just y final is just minus 2. Okay, basically my h divided by 2, and it gives me minus 2. Okay, so what else do I know? Now here I know this y final. This is y final. Now what is x final? Okay, if I get x final, if I get it, and I will get it now, I can say that, well, y, the trajectory of the parabola is something tangent theta naught, because I know theta naught, multiplied by x. So x final will be tangent theta naught x final minus, if I remember correctly, g divided by v naught cosine theta square, and here I will have x final square. So once I get x final, I will know everything, because I know y final and I know theta naught. The only unknown will be the v naught. But let's come to this. So what is the x final? Well, x final now, what you need to know is this. So my vertical displacement from the initial position, so this is initial, and this is final. My vertical displacement is known, it's just minus 2 meters. Now what is my horizontal displacement? I started here and I ended up here. So it will be d plus this portion here, small d. But how can I get small d? Well, I will look at the tangent of this angle here. The tangent of this angle, or the tangent of this angle here, if you want, will be opposite side. What is the opposite side? It will be h divided by 2, basically this, divided by this small d. So that means that small d is just h divided by 2 divided by tangent 20 degree. So let me do that. I know, because I know this is what? This is 2 meters. This is 20 degree. So I can know this d, small d. So this small d will give me 5 meters. So my x final will be just capital D, which is given by the problem, 50 meters, plus small d, which is give me 55 meters. Okay. So now I'm happy. All what I need to do is I will be using the equation of the parabola. Because I know that my biker is going through a projectile motion. I know that x final, and I know x final, y final. And I know y final, by the way, is equal to -2, is equal to x final, tangent theta, which is 20 degree, minus 1/2 of g, this, okay? And I know also here this x final. Basically, I'm telling you in this equation, the only unknown is this v naught. I know everything else. Okay. I know the y final, I know the x final, I know the theta, I know g, of course, and I know cosine theta. So the only unknown will be v naught. So let me solve for v naught, and then you get 28 meters per second square. Bottom line, here, all what I need to know is delta x and delta y. And then I will use the equation of parabola. Delta y is equal to delta x tangent theta, which is the equation of my parabola, minus g divided by v naught cosine theta square multiplied by delta x square. Okay. Is it clear? I am just using the equation of the parabola. Okay. And then I get it. So thank you very much. Tomorrow, inshallah, we will solve the rest as a, we will keep on going and start uniform circular motion. Okay. Thank you. But before I end, let me say this, because I noticed that there is in one section I did not say it. So if you remember, the time I reach the, let me show you what I want you to. Yes, okay. So if I leave this launch point at t equals 0, I reach the range at t final, which is 2 times v naught y divided by g. Okay. And then this is what I did here, and I showed you how I get it. And then I get the range, and then I gave you the formula for the range. Now, for some of you, I have asked you, what is this maximum height here? This maximum height, I'll call it capital H. So the time I reach the maximum height in reality is half of this time, is equal to v naught y divided by g. How do I know? Well, you know that the time I take to rise from here to the maximum height is the same time I will take to go from maximum height to the same height below here. Okay, this delta t here is equal to this delta t here. Okay, so this time is just half of this time, so I will have it as v naught divided by g. But I can show it. I can show you how to get it. How? Well, you know that at maximum height, Vy is equal to 0. At maximum height, I stop moving in the y direction, but I'm still moving in the x direction. So I will stop moving in the y direction. So Vy is equal to 0 at maximum height. And you know that Vy is v naught y minus gt. That means the time at maximum height is just v naught y divided by g. And this is confirming the analysis that I told you before. It's just half t final being this time here. Okay, now once I get the time at maximum height, let me call it th if you want. I can plug it here. I put th here, and I put th here, and I get my maximum height. But I also can use Vy square is equal to v naught y square minus 2g y minus y naught, because I know that along y, I have a constant acceleration motion with an initial velocity of v naught y with an acceleration of ay, which is minus d. So at maximum height, as you know, Vy is equal to 0. So I have 0 is equal to v naught y square minus 2g. Now delta y will be h, capital H. So that means that h will be v naught y square divided by 2g. Okay. So in your formula, I just put the real value for V naught Y, because V naught Y is V naught sine theta. So I said V naught Y square in your formula sheet multiplied by sine square of theta naught divided by 2G. And this is the formula of the maximum height. This is a formula for range. I believe it's in the formula sheet. This is a formula for maximum height. I believe it's in the formula sheet. So redo it. You can convince yourself, okay? So thank you and see you tomorrow, inshallah. Tomorrow, we will start directly from uniform circular motion. And then we will finish this chapter. Very important chapter. Thank you. Assalamu alaikum. Assalamu alaikum. So today we will solve a recitation problem for chapter 4. We already solved this in class. We also solved this problem in class. Okay, these two problems are related to uniform circular motion. That's the important concept of chapter 4. So already solved. Please solve more problems. You go down the slides, you will find more problems on uniform circular motion. Now I will go to the next important concept, which is relative motion. Okay. I will solve, let's say, 2 or 3 problems on relative motion. And then I will solve a couple of problems on projectile motion. Now let's start by this problem. Read the problem carefully. So a plane moves due east in steady wind. The velocity of the plane relative to the wind is 215 kilometers per hour, directed at an angle 30, at an angle theta south of east. So let me draw. This is my x-axis, this is my y-axis, east, north, of course, west, and south. So the plane moves due east in steady wind. Basically, you know that the plane wants to go in the positive x direction. Now here, I will say something here. I said that the velocity of the wind relative to the ground is 65 kilometers per hour directed 20 degrees east of north. Okay. So the question is, what is the magnitude of the velocity of the plane relative to the ground? So you know that the velocity of the plane relative to the ground is equal to the velocity of the plane relative to the wind plus the velocity of the wind relative to the ground. Relative velocity, Pg is equal to Pw plus Wg. Okay. This is a fundamental relationship that I showed already in class. Now, what is the velocity of the plane relative to the wind? This is a second sentence here. The velocity of the plane relative to the wind has a magnitude of 215 kilometers per hour directed at an angle theta south of east. So east is here, south of east theta, this is it. So this is theta, south of east, okay? Now this velocity here, V, is VPW. And you know that the magnitude of VPW is equal to 215 kilometers per hour. I will leave everything in kilometers per hour, and at the end I will just convert it in meters per second. So this is VPW. Now, the velocity now of the wind relative to the ground, V, wind ground, has a magnitude of 65 kilometers per hour. Now the direction is 20 degrees east of north. So as you know, this is the north direction, parallel to this positive y. 20 degrees east of north is this. 20 degrees in the direction of east. So this is it. This is 20 degrees. And this vector here is the velocity, wind with respect to ground. Now, what does it mean? So it means here that the velocity of the plane with respect to ground is a sum of these two velocities, and this velocity is purely along positive x, because I know that the plane is moving due east in steady wind. Relative to the ground, velocity of the plane relative to the ground is moving due east. Okay, it only have a positive direction, a positive x direction. Okay, good. So I represented all my vectors. I write them in magnitude angle notation. Now let me exploit this relationship here. This is a vectorial equality. That means it's true along x and it's true along y. So along x, I will have VPGX is equal to VPWX plus VWGX. And also along y, I just replace here by y and then I got it. Now, let me just do it along x here. What is VPGX? VPGX is purely along x. VPG here, let me write its component. It will be VPGX, which is just VPG. And VPGY is equal to 0, because it's purely along x due to this statement, the first statement. Now VPW. What is the x component of VPW? Of course, it will be VPW cosine theta. And it will be minus VPW sine theta. Okay, so I will have 215 cosine theta. Okay, so because the x component here is just a cosine and it's positive. The y component here is sine and it's negative. That's why here I'm writing minus 215 sine theta. Okay, so I know VPWX, VPWY. Now what is VWG? X and y. It will be magnitude of VWG, which is 65 cosine which angle? Because I need the angle between VWG here and the positive x-axis. So this is the angle that I want here. So it will be 90 minus 20. So it will be 70. So it will be 65 cosine 70, and it will be here 65 sine 70. Some students, they will say it will be 65 sine 20. Why? Because if this is 20, this is opposite, so it's a sine. And then along the y-axis, they will say 65 cosine 20. Because this is 20 here, so on the y-axis it's positive, and this is the cosine. It's an adjacent angle, an adjacent side. Okay, so this is the same. You know that basically sine 20, of course, is equal to cosine 70. Okay, because these two angles are complementary. You do it the way you want, but get me the right answer. That's what I'm interested in. Okay, so along x, now let me just gather all this data along x. So along x, I will have this VPG along x, which is just VPG. This guy along x will be what? It's just 215 cosine theta. And this gentleman here along x is just plus 65 sine 70. Okay, now along y, I will have this gentleman along x, which is 0, is equal to this gentleman along y, sorry, because I'm so this VPG along y is 0, VPW along y is equal to minus 215 sine theta, and VWG along y is just 65 sine 70 degree. So now I have my two equations and two unknowns. The unknowns are the angle theta and VPG itself. Okay, these are my two unknowns. Now you know how do I do to solve the system of equation of two unknowns. So here first I will start by theta. So this will give me theta. I will use this. So theta will be equal to what? So basically I will have 215 sine theta is equal to 65 sine 70. That means that theta will be what? Sine inverse of 65 divided by 215 multiplied by sine 70. You do the calculation, you will have an angle theta of what? Of 17.6. I leave it in three significant figures, okay? So once I get theta, which is 17.6, I will come in the first equation, basically along x. I will just plug it in the first equation and then I'll get my VPG. So your VPG will be just 215 cosine 17.6 degree plus 65 sine . Okay, here I made a mistake. It's a cosine. Okay, so here it's a cosine, right? Cosine 70 degree. So here it's a cosine. Okay, because it's a cosine 70. So here it's a cosine 70. Okay, so you do it, you will get in kilometers per hour, 227 kilometers per hour. You have to put it now in meters per second. It will be 227. You know that 1 kilometer is 1,000 meters. 1 hour is 3,600 seconds. So it will be just 227 divided by 3.6 meters per second. And this will give you 63.4 meters per second. Okay. Now let me go to the second problem here. And let's read it carefully. We have a 200-meter wide river that has a uniform flow speed of 3 meters per second toward the east. So let me just draw that. Okay. So let's assume that this is my x-axis and this is my y-axis. Of course, this is east, this is north, this is west, and this is south. Okay, good. Now the velocity of the river with respect to the ground is going towards the east. So it will be just plus 3 I hat, basically 3 along x, positive x, and 0 along y direction. Now here I gave you the width here, okay? This width, let me call it D, is just 200 meters. Now a boat with a speed of 8 meters per second relative to the water leaves the south bank and heads in such a way that it crosses a point directly north at its departure point. So basically here, my boat leaves here and the boat wants to go to the north here, exactly at this point here. And he knows that the river is flowing in this direction. This is the velocity of the river with respect to the ground. And I know it already here. Now, what do the boat has to do? If he wants to end up here, he wants to go toward this direction. He will go opposite, okay? He will go a little bit against the flow of the river. So this is the velocity of the boat with respect to the river, okay? Such that the sum of these two velocities will give you the velocity of the boat with respect to the ground, okay? Because he wants to cross directly here. He wants to leave the south and go to the north bank here. So he has to go a little bit against the flow of the river, and the river will push him a little bit toward the right, and he will end up exactly here. Now let's write that. You know that velocity of the boat with respect to the ground, okay, is equal to velocity of the boat with respect to the river plus velocity of the river with respect to the ground. Now what I need to do here is I just need to write one by one, okay, component by component. So this is a vectorial equality. That means it's true along the x-axis, but also along the y-axis. So along the x-axis, what I will have? I will have VBGX. By the way, what is VBGX? As you see here, VBG does not have any component along x. It should be purely along y. So VBG here has 0 component along x, and along y, he will have a magnitude of VBG along y. So VBGX is 0. Okay. So 0, what is VBRX? Boat river along x. Okay. So now I know the magnitude. I know the magnitude V boat with respect to the river. This is a speed of 8 relative to the water. Okay. So this is 8. I know the magnitude, but I don't know the angle. Okay. Here's the angle. I will call it the angle between positive x, basically I hat, which is in this direction, and VBR. So basically the angle that I'm talking about is this angle here. Okay. Good. Now I know the magnitude, and the angle, I don't know it. Okay. I will just call it theta. So, but VBRX will be magnitude of VBR, which is 8, cosine the angle theta. Okay. So let me write it here. VBR vector will have 2 components. Along x, it will be VBR cosine theta, and along y, it will be VBR sine theta. This is why I'm insisting for you to watch a video on vectors. Once you know vectors, this will be simple for you. And now I hope that by now, every one of you has watched that video and he knows vectors very well. Okay, so this is VBRX is just magnitude of VBR, 8 cosine theta. Now VRGX, well, I know VRG is here. It has 3 along x and 0 along y. So here it's equal to 3. So along x, now I can get what is theta. Basically, theta will be just cosine inverse of -3 divided by 8. You use it, you will get 112 degrees. Now this angle here is of course 112 degrees, and you can see it, it's bigger than 90 degrees. Other people, they will consider this angle here, okay? They are free to do it, okay? Here I'm just taking the angle between the positive x-axis and the vector. But as you know, and as we already discussed, you can choose your angle with reference to a different axis. You can choose it with reference to the positive y-axis, to the negative x-axis, to the negative y-axis. But here I chose to use the positive x-axis as usual. And the angle here is 112 degrees. Now, once I get it, I use this same relationship here. Now I will project it along y. Along y, I will just have VBG along y, which is just VBG in magnitude, is equal to VBR along y. What is VBR along y? It's just 8 sine theta. So 8 sine, now I know theta is 112 degrees. Plus VRG. Now what is VRG along y? VRG along y is just 0 here, as you can see. And this will give me what? This will give me 7.41 meters per second. So this is a velocity of the boat with respect to the ground. And it's only have a y component, okay? Because I want to start here and end up exactly at the north. So this speed is just equal to the width of the river divided by the time I take to cover that width. So that means the time which is asked here, how long does it take for the boat to cross the river? So I'm looking for the time is just the distance here, 200 meters divided by the speed, 7.41 meters. And that will give you what? If you do the calculation, how much did you get? 27 seconds, okay? I want it in two significant figures here. As you notice, I have two significant figures, two significant figures, two significant figures. So I want it in two significant figures. I hope it's clear, okay? So this is just what I did here in the solution. It's already given. Now let me look at this problem here. At time t equals 0, a particle leaves the origin with a velocity 6 meters per second in the positive y direction. And the particle moves in the xy plane. So I have a two-dimensional motion with a constant acceleration. Okay, this is the key word. And I give you the constant acceleration along x and along y. Now the question is, at the instant the particle reaches its maximum y coordinate, find the velocity of the particle. So at t equals 0 here, the particle is at the origin. So r0, which is r at t equals 0, is equal to 0. That means x0 is y0 is equal to 0. I start exactly at the origin. Now, what is my initial velocity? v0. v0 is 0 along x and plus 6 meters per second along the y direction. Okay, so this is v0, v0 x, and this is v0 y. Okay, now what is the acceleration? Look, the acceleration is constant, so I can use constant acceleration equations. And ax is equal to plus 2 and ay is equal to minus 3. Okay, so there is a positive acceleration along x and a negative acceleration along y. Okay, and look carefully at the problem here. Now I will discuss a little bit here. You see here I have a positive velocity, initial velocity along y, and then I have a negative acceleration along y. That means I will be initially moving along the positive y direction, upward, but there is a force, an acceleration which is downward because it's negative. So I will be slowing down and I will eventually stop in the negative, in the positive y direction. And then I will start moving in the negative y direction. Okay, so the acceleration is constant. So you know constant acceleration motion. So since A is constant, that means that V is just V0 plus AT, okay? So what does it mean here? It means that V has two components. This is true along X and along Y. That means Vx is equal to V0, which is 0, V0x, plus AXT, which is plus 2t. And Vy at any time will be V0y, which is 6, plus AYT, so minus 3t. This is my velocity along X, this is my velocity along Y. Now what is my position? R minus R0, which is 0 here, by the way, is equal to what? V0 t plus half a vector t squared. So that means R will have two components along X. So along X, it will be V0 x. Basically, I will just have this. I will have t squared. And along Y, I will have 60 minus 3 divided by 2 t squared. Okay. Here I just apply, it will be V0 x t plus half ax t squared. Here it will be V0 y t plus half ay t squared. So I just apply it here to my problem. Now at maximum y coordinate, And I told you, physically, I know that it will have a maximum y coordinate because my initial velocity along y is positive and my acceleration along y is negative. So I'm going up, but I'm slowing down. So I'll stop on the y direction. So at maximum y coordinate, whenever you hear a maximum or minimum, so that means the derivative of y with respect to time is equal to 0. Actually, it means at maximum y coordinate, you know that at maximum height Vy is equal to 0. Okay, so that means 6 minus 3t is equal to 0. That means t is equal to 2 seconds. Now, once I get my time at 2 seconds now, what is the velocity? I just take 2 seconds and I plug it here. Okay. Of course, at t equal 2 seconds, you know that Vy will be 0. So the velocity V will be just V naught x at 2 seconds I hat plus Vx at 2 seconds and Vy at 2 seconds j hat. So this guy is 0. So it will just give you 2 multiplied by 2, so 4 I hat meters per second. Don't stop here. Now, if I ask you the position, what is the actual position at maximum height? So basically, you take your 2 seconds, you just plug it here, you get your x coordinate at maximum height and your y coordinate at maximum height. Okay. So R at t equal 2 will give you your coordinates x2 and y2, you know, at maximum y coordinate at max height. And there are many other problems that I can ask you, okay? I can ask you what is the displacement, what is instantaneous, let's say velocity at another time, etc., etc. Okay, good. So along the x direction, there is no acceleration. So this is nice. Okay, so this is what we did here, and the solution was already given. I just wanted to discuss that. Okay, now let me go to the next problem here. So read the problem carefully and then we solve it quickly together. So here, as you see in figure 3, the particle A moves parallel to the x-axis along the line y is equal to h with a constant velocity of magnitude 2.5 meters per second. At the instant the particle A passes the y-axis, the particle B is leaving the origin with a 0 initial velocity. This is very important, and constant acceleration. So the particle collides after some time. What is the time needed for the two particles to collide? Well, you know, for particle A, let me write it this way. You see that basically you have constant velocity, right? So V is just constant and is equal to plus 2.5 I hat. Of course, the unit is meter per second. Okay. Of course, for particle A, the acceleration for particle A basically is 0 along both directions. Okay. So the velocity, of course, is plus 2.5 along the x direction and 0 along the y direction, the velocity of particle A. Now, what is the position of particle A? Well, you know that the position of particle A, that's simple. He has an x component here. The x coordinate will be just plus 2.5 multiplied by t, and the y component of particle A is just h, by the way. And I did not give you h here, but anyway, you can find it later if you want. Okay. Now for particle B, on the other hand, you have an initial velocity of particle B, which is 0. Basically 0 along x, 0 along y. But the acceleration of particle B is what? AXB is equal to 0.35 and AY is just equal to 0.2. And it's constant. So I can write what is the position of particle B. Of course, the position of particle B at any time minus the initial position of particle B, basically 0, because particle B starts from the origin here. So this is 0. So the position of particle B has two components, x of B. So it will be x of B. You know, if I have constant acceleration, it will be V naught x B, which is 0 multiplied by t, okay, plus half AX. Here AX is 0.35 t squared. And YB at any time is equal to Y naught, which is 0, plus V naught BY, which is 0, okay, plus half, multiplied by t, of course, so 0 multiplied by t, plus half AY, or AY here is 0.2 multiplied by t squared. Okay. So when they meet, what will happen? Of course, RA at collision, time of collision, RA at that time equal to RB at that time. That means XA at that time will be XB at that time, and YA at that time will be YB at that time, and it will be H. Now I will just use this one. So basically I have to solve this equation. 2.5 T is equal to half 0.35. Okay, here you see I put 32. Of course it's 35 because the problem is saying 0.35. Have 0.35 T squared. Okay. So this either T is equal to 0, which is not the case, or T is equal to, let's say, 5 divided by 0.35. You just solve this problem. Okay. So 5 divided by 0.35 will give you 14. Okay, so your answer is 14 seconds. So this is the answer. Now I can ask other questions, many other questions. For instance, what is this H here? Now you know that now I know the time, I just plug it here and I know what is H, okay? So whenever you solve a problem, ask yourself, which other question could I have asked? Well, this is a projectile motion, but it's kind of straightforward. I will let you solve it by yourself. Okay? The solution is given here, okay? So first I give you the speed and the launch angle. So this is the speed. And the launch angle is the angle the velocity is doing with the positive x-axis. Of course, here, this is my positive x-axis. Okay. So of course, this is 100. So this y final here is just minus 100. Minus 100 because I took here as my 0, right? So it's 100 below. So you will have, to get the time, you will just use this equation. Okay. Now, minus 100 will be equal to V naught Y. So what is V naught Y? Of course, you know that V naught has two components, V naught X and V naught Y, and V naught X is V naught cosine theta naught, and V naught Y is V naught sine theta naught. You know this very well, because V naught is doing like this, and theta naught is this. So this is the X component, and this is the Y component, and this gives you this. Minus half gt squared. So you see minus half gt squared is this, and now you will have a quadratic equation. I hope every one of you know how to solve a quadratic equation, okay? You know how to solve it. You know how to solve it quickly using your calculator or just using the determinant, right? So you do it, you get two answers, a negative term and a positive term. Of course, the positive term will be what I need, okay? So what is the magnitude and direction of the velocity of the ball just before it hits the ground, you know that Vy is this and V naught Y is constant. V naught X, sorry. Vx is equal to V naught X is V naught cosine theta, and this is constant. It's a projectile motion. There is no acceleration in the X direction. Along the Y direction, you know that Vy is just V naught Y minus GT. So you just do it and you get it. And then you can get the magnitude, and the magnitude is here and the direction is here, okay? So here we get it in unit vector notation. I know Vx and Vy at that time of hitting the ground. Of course, I know the time because I calculated before. Now you know how to go from unit vector notation, from components to magnitude, direction, okay? Okay, so V is just square root of Vx square plus Vy square, and theta is tan inverse of the Y component Vy divided by Vx. And you see that Vy here is negative, and I see it. When I hit the ground here, theta is negative. You see that this is in the fourth quadrant. So this is straightforward. I'll skip it. Now let me solve this problem now. Now read the problem carefully. So a baseball hit at ground level here, okay, is shown in figure 1. The ball is observed to reach its maximum height above the ground after 3 seconds. 3 seconds after being hit. And then 2.5 seconds after reaching the maximum height, the ball is observed to barely clear a fence of height h, that is at a horizontal distance of 97.5 meters from the point where it was hit. Basically, you see it here. This distance here is 97.5. So the question is, what is h? What is the height of the fence? I can also ask you, of course, what is the maximum height? Okay. So here, 2 seconds after being hit, I reach the maximum height, and then 2.5 seconds later. So here, basically, this time here is 5.5 seconds because it took me 2.5 seconds to go from here to here. Okay, this delta T. Okay, so this is a projectile motion. Well, you know how to solve a projectile motion, guys, okay? Projectile motion, by definition, has a constant acceleration. This is the acceleration, A. And the acceleration is just the free fall acceleration. So AX is equal to 0 and AY is equal to minus D. I will remind this, okay? This is in your formula sheet and we studied this already. So now from the acceleration, well, I know that I can get the velocity at any time. Velocity will be just V naught plus AT, okay? What does it mean? That means that my velocity has 2 components, Vx at any time and Vy at any time. And Vx will be just what? V naught x. And I know, by the way, what is V naught x? It's just V naught cosine theta naught, okay? This is basically this x component, okay? This is constant. Y, there is no acceleration along x. And Vy is, of course, V naught y minus gt. Got it? Now from this, I can get the position. R minus R naught is just V naught T plus half A vector T square. Okay, good. So that means component by component, this is true because this is a vectorial equality. That means along X, I will have X minus X naught is just equal to V naught X multiplied by T. AX is 0, so I can forget about that. Y minus Y naught will give me V naught Y T minus half GT square. Okay. So this is just a reminder of what we did in class in the lecture. And this is in your formula sheet. This is in your formula sheet. It means this. Okay. Now let me translate the data of the problem. So the first data I can use is this horizontal distance here. I said here that X minus X naught is equal to 97.5. So this will be equal to V naught X multiplied by T. And I know the time. The time is 5.5. So that means V naught X is just 97.5 divided by 5.5. And this will give me what? 17.7 meters per second. I write everything in three significant figures. As you notice in the problem, I have all in three significant figures. Okay, good. 3 or 2, you will see what are the answers. But let me keep it in three significant figures. I will not really need this. So this, I will keep it for as a questions, okay? But now let's exploit, because here the question is to find this vertical displacement here, H. So the vertical displacement I will have y minus y naught, basically H, is equal to what? V naught y multiplied by t, and t here is 5.5 as you see, minus half g, which is 9.8, t square, which is 5.5 square. So here's the only unknown is this V naught y. How will I get the V naught y? Well, I exploit the maximum height here. As you know, at maximum height, as usual, okay, maximum height, maximum y coordinate, maximum x coordinate, that means that the derivative of y with respect to time is 0. So basically at maximum height, Vy is equal to 0. The velocity along y is 0 because I stop going up in the y direction. So Vy is equal to 0. And you know that Vy is V naught y minus gt. So that means that V naught y is just g 9.8 multiplied by the time at maximum height, which is 3 seconds. So I got V naught y. Once I get V naught y, I will just plug it here, and then I will get my h. Okay, and you do it properly, you will find 13.5 meters. Clear? Okay, good. So you see 13.5 meters is my solution here. Of course, in the slide, I use different kind of notation, but this is straightforward and you should get this very quickly. Okay, now let's go back to relative motion. This problem is very important. Let's say Ahmed walks up a stalled, not moving escalator of length L. Okay. When standing on the same escalator, now moving, so only the escalator is moving and Ahmed is just standing. So the person, Ahmed, is carried up in 60 seconds. Okay. So let me read again. A person walks up a not moving escalator of length L in 90 seconds. When standing on the same escalator, now moving, the person is carried up in 60 seconds. How much time would it take that person to walk up the moving escalator? Okay, this is an A+ question. Okay, now, as the question before, by the way. Okay? So how do we do? Let me just draw. Let's say this is the escalator. I just put it here. Let's say this is the top view. This is my escalator. It has a length, what? Capital L. Okay. Now let's look at it. So the person is walking up the escalator of length L in 90 seconds when the escalator is not moving. So let's see what is the velocity of the person with respect to the ground. Okay. So the velocity of the person with respect to the ground is just the velocity of the person with respect to the escalator plus velocity of the escalator with respect to the ground. Okay. Relative velocities. Okay. So now here, everything is moving in one dimension, in one direction. So let me just consider this as the x direction. Along y, nothing happens. So along x, I will just have v p g is equal to v p e plus v e g. Velocity of the person with respect to the ground is velocity of the person with respect to the escalator plus velocity of the escalator with respect to the ground. Now, in the first case, the person is walking up, but the escalator is not moving. So the velocity in the first case, VEG is 0 because the escalator is not moving at all. So basically this part is equal to 0 here. So that means the velocity of the person with respect to the ground is just equal to the velocity of the person with respect to the escalator, because this part is 0. And this is equal to what? In the first case, of course, I mean, this speed or this velocity is just the length of the escalator divided by 90 seconds. Okay, and this is just the speed of the person with respect to the ground. But since this is 0, that's the speed of the person with respect to the escalator as well. Now, in the second sentence here, I'm saying that now when standing on the same escalator, now moving, now the escalator is moving. Okay, but the speed, velocity of the person with respect to the escalator is 0, because the person is on the escalator and the person is not moving. Got my point? Okay, so that means what? That means that if I have VPG is equal to VPE plus VEG, now the escalator is moving, so this is different from 0, but this is equal to 0 here. Okay, because I'm standing on the escalator. This is like the problems that I sent to you, the videos that I sent to you. The gentleman is throwing a ball up and the car is moving along the X direction. Do you remember that problem that I sent to you? You know, this projectile motion, but the gentleman throws the ball up and catch the ball after, because the ball is going in the project in a projectile motion. Okay, but they have the same Vx along X. Anyway, have a look at that videos. By the way, watch the videos that I'm sending you. It will help you, you know, put what we do in real case situation. So here I'm saying that the man is standing. So velocity of the person with respect to the escalator is 0. So velocity of the person with respect to the ground in this case is just equal to the velocity of the escalator with respect to the ground, since this gentleman is 0, VPE is 0. And now it will be what? L divided by 60. Okay. So now this is the velocity of the escalator with respect to the ground. It's just L divided by 60. Okay. So intrinsically, specifically, the escalator is going with respect to the ground with this speed, L divided by 60. And intrinsically, the person is going at a velocity with respect to the ground of L divided by 90, intrinsically. Okay. Now the question is, how much time would that person take to walk up the moving escalator? Well, now the person is moving with respect to the ground, but also the escalator is moving with respect to the ground. So now let me just say that VP with respect to the ground is just VP with respect to the escalator plus V escalator with respect to the ground. Okay. So now, what is V person here? In this case, both of them are moving. The person is moving up, but also the escalator is moving. Okay. So V person with respect to the escalator will be what? It will be this. V person with respect to the escalator is L divided by 90. Okay. V escalator with respect to the ground is also L divided by 60. Okay. So I get this L divided by 90, L divided by 60. And this now is equal to what? Of course, it will be equal to L. It's the same distance divided by the time that I'm looking for. The new time, of course, it will be shorter than the time of the escalator alone or of the man alone. Okay. So this is the time that I want here. So L will simplify, and then I will just get T is 1 divided by 1 divided by 90 plus 1 divided by 60. This will give you 36 seconds. If the gentleman is moving at the speed and the escalator is moving at the speed, now both of them are moving, of course, the gentleman will have a shorter time to cover the same distance, and that is equal to 36 seconds. So here, let me just discuss this a little bit here. So this is what we call, this is an average, okay? But this is what we call a harmonic average, okay? You have different type of average in maths. Let's say your grade is x1, x2, xn. The arithmetic average is just x1 plus x2 plus xn. These are your different grades divided by the number of quizzes. This is what we call arithmetic average. You will study this in statistics. But also you have what we call a harmonic average. The harmonic average, so H, okay, is just here, 1 divided by x1 plus 1 divided by x2 plus 1 divided by xn. And this is what is appearing in these cases. And if you remember in chapter 1, at some point, we were calculating what is the average speed. The average speed was kind of 1 divided by V1 plus 1 divided by V2, etc., etc. Have a look on chapter 1. You will see chapter 2, okay, one-dimensional motion. Okay, you will see this type of, and you have another type of average called geometric average. Okay, and this is a square root of n, x1, x2. You take the product of all your grades and you take this, the root to the power n, okay? Anyway, that's not the object, that's math. You will study that in statistics. So you see we get 36 seconds. Now let me solve this and maybe solve this and then I will stop because I want you to solve the rest, okay? So here I have a boat that takes 3 hours to travel 30 kilometers downstream a river. So you need to understand what is downstream a river. Then it takes 5 hours to return upstream the river. How fast is the river flowing? Let's draw. This is my river. This is the sea. You know that rivers are going to the sea. So let's say the river is going from the mountain toward the sea. And this is the velocity of the river with respect to the ground in reality, okay? But everything here is okay, the velocity of the river with respect to the ground, okay? Now downstream means what? I'm going in the same direction. So the velocity of the boat with respect to the river is going in the same direction as the velocity of the river with respect to the ground. This is like your airplane, which is moving in the same direction as the wind. I used to go to LA, for instance, frequently when I was doing my PhD. So when you go, sometimes it's fast. When you come back, it's slow. Why? Because of the direction of the wind. So here, when I go in the direction of the river, I will go faster. That's why I'm taking 3 hours. Now, when I'm going upstream, and this is what we call downstream, going in the same direction as the river. Now, upstream, I'm climbing up the river now. So the river is still moving in this direction, but now my velocity of the boat with respect to the river is moving in this direction, in the negative direction. So I'm climbing up, so I will take more time. That's why here I'm taking 5 hours. Okay, now let's put it here. So the velocity of the boat with respect to the ground, okay, is equal to, here everything is one-dimensional, okay? So let me put the vectors. No problem. So is equal to velocity of the boat with respect to the river plus velocity of the river with respect to the ground. Okay. Now let's look at the first case when I'm going downstream. Okay. Now velocity of the boat with respect to the ground will be, because anyways the boat is moving in the positive direction. Okay. So the velocity of the so I'll project, of course, along the x-axis. Velocity of the river with respect to the ground, I'll just call it v boat, okay? With respect to the river, I will call it just v boat. And the velocity of the river, I will call it v river. So the two speeds are adding up, okay? Because both of them are moving in the same direction. And this will be equal to the distance here, which is 30 kilometers divided by 3 hours. So this is equal to 10. I have my first equation, velocity of the boat plus velocity of the river when the two speeds are adding up in the downstream case is equal to 10. Of course, I mean 10 kilometers per hour. Okay. Now in the second case, upstream, I project also along the x direction. I project this relationship along the x direction. Now the velocity of the boat with respect to the ground. Now what is the velocity of the boat with respect to the river? It's negative because the river is, climbing up, is going in the opposite direction of the flow. So we will have minus v boat plus the river is still going in the positive direction, as you can see it here, plus v river. And this is equal to what? This velocity here. This is equal to the time. I still cover 30 kilometers, but I cover it in less time, in more time, so 5 hours. Okay? Because these two are opposite. So in reality, I'm going slower because the river is opposite to the motion of the boat. So now I have my second equation. I have just minus VB plus VR is equal to 6. Now I have my two equations, two unknown, and you know how to solve a system of two equations, two unknown, substitution, addition, or you can use a Cramer method. So here's the best thing is to use addition. When you add these two gentlemen, V boat will go away and you will find what? 2 times V river is equal to 16. That means V river is just equal to 8. Okay. Now what is so 8 kilometers per hour is the speed of the river. Now what is the speed of the boat? The speed of the boat will be equal to what? 2, right? Now there is a mistake here. So here I will have this, and here I will have V boat. Okay, so when I do this, I add them, I will have this. Okay. No, because the V river should be bigger than the, the V boat should be bigger than the V river. So basically, the V boat will be 16 and the V river will be 2, right? Yes, this is what I expect. Okay. But how I will do it here? Yes, because here I'm moving in the negative direction. So here it will be minus. So here it will be minus. Okay. In other words, basically, V river, let me just put it this way. So here I'm going in the negative direction. So here it will be minus because the displacement is negative. So in other words, the second equation is just V boat minus V river is equal to 6. Yes, this is the second equation. So that will give me, as we said, V boat is equal to 8 and V river is equal to 2. Okay, good. Or I can just take, say here, and I take the absolute value if you want. And taking the absolute value will give me this. Because anyway, I know that V boat will be bigger than V river. Why? Because otherwise I will never reach my destination when I'm going upstream. Okay, so this is why here I'm taking absolute value here. Okay, yeah, there are many ways I can justify this. Okay, so bottom line, V boat is 8 and V river is 2 kilometers per hour. There is this problem also. I want you to solve it. Okay, simple, straightforward, relative velocities. This problem, which is the same, this is uniform circular motion, easy, conceptual, you can solve it. This is uniform circular motion. We solve this problem, something similar or harder even in yesterday's lecture. You can solve this, you can solve this. So please solve all the problems and you will be ready for the exam. Just on a final note, please make sure that you understand vectors. As you see, we are using vectors extensively. Okay, so good luck and see you on Sunday. I wish you the best incoming quiz. Thank you. Assalamu alaikum wa rahmatullah.